All right, guys, we're just going to talk a little more about confidence intervals today. So why settle for 95% confidence when estimating an unknown parameter? Do larger random samples yield better intervals? That's what we're going to talk about. Okay? Yes, smaller is better because then you're closer to the true mean. All right? So we're going to look at some intervals and what happens when we change the confidence levels and when we change the sample size. So let me pull up this lovely website again. All right, so we've got our samples of 25. Notice the length of the confidence intervals, and I'm at 95%, right? What if I change this to 90% and I do another sample? What happens to the length of the interval? And let's go even further. Let's go down to like 80%. Ooh, what happens to the length? Can you guys tell? No? This confidence interval, how long it is. Okay, so here we go. 80%, look at how long it is. Now let's go to 90%. What's happening? Let's go to 98%. Okay, good, good. So all that's happening, you guys, is as I get an increased confidence level, what happens to my interval? It's also getting wider. Is that better or worse? Yeah, it's worse as far as accuracy is concerned, right? We're giving ourselves a wider range of values. So increasing my confidence level is going to increase my interval, which doesn't really help. So the less confident we are, the smaller the interval, okay? All right, and the other thing we want to talk about is changing the sample size. So let's put this back to like 95%. And let's change our n. Let's go up to 150. Ooh. What happens to the length of the interval? Okay. And if I go down to 15, what happens to the length of the interval? So what's better, you guys? A bigger sample size gives a more accurate confidence interval. Okay. All right. So here's a bunch of confidence intervals. This is my like X bar in the middle. This is my margin of error. Which one of these is the 80% confidence? Which one of these is the 90% confident? And which is the 95% confident? 80 is the shortest one. All right? So we pay a price for higher confidence, and the price is a wider interval or a less accurate interval. Okay? And again, back to that extreme confidence. What if we want to be 100% confident in the proportion of all U.S. adults who use Twitter? What would my confidence interval be if I'm talking proportions and I want to be 100% sure about my guess on proportion of people who use Twitter? What's my interval going to be? 0 to 100. I'm 100% sure that the proportion of U.S. adults who use Twitter is 0 to 100. Make sense? So that's stupid because it doesn't help us do anything, right? All right. And then for increasing the sample size, so we just talked about that, increasing the sample size does what to the length of my interval? Shortens it, which makes it more accurate. All right, so make a note about both of these things. But increasing the sample size shortens the interval, making them more precise estimates because there's less variability. So it's essentially reducing the margin of error, which is the length of the interval. All right, eventually we're going to fill in this formula, but this is the generic formula for confidence interval. We do the statistic plus or minus the critical value times the standard deviation of the statistic. The only piece of this we haven't learned how to do is the critical value part. But the statistic would be either like an X bar or a P hat. Well, we will learn how to do the critical value part. And then the standard deviation, well, if I'm doing means, it's our formula for standard deviation for means. And if I'm doing p's, it's our formula for standard deviation of p's. Okay? So again, because we're multiplying by something that's dividing by n, right? I'm dividing by n, so as n increases, variability decreases. Same thing you just wrote down on the last slide comes from those formulas where we're dividing by our sample size n. Okay? So 2 things to write down that we just talked about, but go ahead and write down. Margin of error gets smaller when, so the margin of error is from here to here. It gets smaller when the confidence level decreases, right? If I'm 80% confident, that's going to be a smaller interval. And it also gets smaller when the sample size increases. Those are the 2 things you have to know. Oh, sorry. All right, so a couple other things to keep in mind. Our method of calculation when we do confidence intervals assumes that the data comes from a simple random sample of size n from the population of interest. So there's other types of random samples we talked about. Remember stratified and cluster? You guys remember what stratified is? Right. It's not blocking because that goes with experiments. This goes with samples, and it's when you group them by their alikeness, right? And then cluster is representative of the population, but it groups like all different stuff into it. So it's grouping by location. All right. So those might be preferable, but they require more complex calculations than the ones we're going to use. So you just assume all of these come from a simple random sample. All right, which it has to tell you in the problem that it comes from a random sample. All right. And also the margin of error in a confidence interval covers only chance variation due to random sampling or random assignment. So there could be practical difficulties. So if you guys remember undercoverage and non-response, you guys remember those? People who don't respond, or undercoverage are like you forget all the people in jail or something. That can lead to additional errors that may be larger than this chance variation. So basically, you got to think about how you're sampling ahead of time and make sure you don't have those errors because it does not account for those in confidence interval. Just random thoughts for the day. Pretty much that's it.